Good morning everyone. Welcome back in this class. Today we will discuss about the most important topic of class 9 science, that is the work, energy and power. So in this sequence we will discuss in this video that is the work done when displacement is not direction of the force, and third is the factors affecting the work, and fourth is no one. So now let us start first term of in this video, that is the work done. So dear student, as you know that work done, we can say that in ordinary language, work done means an activity. Now in the term of physics, we can say that work done if a force act on any object, then object displaced along the direction of the force, it is said to be work done. So it is clear that work done equal to force into displacement along the direction of force. So it is clear that work done, force into displacement along the direction of the force, means if the force act on any object, then object displaced along the direction of the force, it is said to be the work done. Now we can add here W equal to F into S. So it is clear that work done is same as the product of the force and displacement along the direction of the force. Now second term is here work done when displacement is not direction of the force. So it is clear that if the force act on any object, then object displaced along the direction of the force. So we can write here W equal to F into S. Now the second condition, work done when displacement is not along the direction of the force. Here the some example. Now suppose that if the force along the AC, force act along the AC and the displacement along the AB. So in this condition, work done equal to W equal to F into S cos theta. So in this condition, force act on the AC along the AC and the displacement along the AB. So in this condition, work and displacement is not in the same direction. So in this situation, suppose that the angle between force and displacement is here theta. So we can write here work done equal to W equal to F into S cos theta. So it is clear that if the force act on any object and object displacement along the direction of the force, so we can write here W equal to F into S. And the next condition, when the force act on any object but displacement is not along the direction of the force, so we can write here W equal to F into S cos theta. So here theta is angle between force and displacement. So in this condition, work done depend on the angle between the force and displacement. So we know that here in the term of cos theta, then theta equal to 0, 30, 45, 60 and 90. Then in the term of cos, then value of cos 0, we know that here that is a 1, and value of cos 30 root 3 by 2, and cos 45 1 by root 2, and cos 60 1 by 2, and cos 90 0. So it is clear that work done depend on the angle between the force and displacement. So it is clear that if the angle between force and displacement is minimum, then work done will be greater. If theta, now the first condition here, if the angle between the force and displacement, if the theta is minimum, then work done greater. Now the first condition is here, if the theta is minimum, then work done is greater. Now second condition, if theta is maximum, then work done minimum. And now the third condition is here, if theta equal to 0, then theta equal to 90, then work done 0. So work done depends on the angle between the force and displacement, and the angle between the force and displacement is depend on its value. When if theta is minimum, then work done is greater. So it is clear that theta is minimum. Now suppose that theta equal to 0, then we can write here W equal to F into S cos theta, then W equal to theta is here, theta equal to, if the theta equal to 0 means the value of between the force, the angle between force and displacement is 0, then theta equal to 0, then F equal to S cos 0, and we know that here the value of cos 0 is equal to 1, so we can write here W equal to F into S into 1, then W equal to F into S. So it is clear that if the theta is minimum, then work done is greater. So here W equal to F into S cos theta, then put the value of cos 0 is here, and the value of cos 0 equal to 1, then F into S, then work done equal to force into displacement. Means the force act on object, then force and displacement is in the same direction. So work done equal to F into S. Now the second condition here, second is the if theta is maximum, then work done minimum. And third condition, if theta equal to 90 degree. So it is clear that we know that here W equal to F into S cos theta, then W equal to F into S cos 90, then W equal to F into S and we know that here cos, the value of cos 90 equal to 0, then cos 90 equal to 0, then W equal to 0. So it is clear that if the angle between the force and displacement is 90 degree or force and displacement perpendicular to each other, then work done equal to 0. So work done depends on the angle between the force and displacement, and the angle between the force and displacement is based on the three conditions. First condition is here, if theta is minimum, so it is clear that the angle between the force and displacement is minimum, then work done greater. So it is clear that if the value of theta equal to 0, then cos 0 equal to 1, then put the value of here in the term of W equal to F into cos theta, W equal to F into S cos 0, then value of cos 0 equal to 1, then W equal to F into S. So it is clear that force act on any object, then displacement along the direction of the force, then work done is maximum, will be maximum. Now next condition, when the theta is maximum, then work done minimum, and third condition here, theta equal to 90 degree, then work done is 0. We know that here W equal to F into cos theta, and the angle between force and displacement, if the angle between force and displacement is 90 degree, then W equal to F into cos 90, and we know that here the value of cos 90 equal to 0, then W equal to F into S into 0, and W equal to 0. Now the next is here, that is the no one. So in the term of work done, there are the two conditions. There are no work. The first condition here, when the force acts on any object, then displacement will be displacement is 0, then work done will be 0. If the force act on a body or object but unable to displace it, then work done is 0. So it is clear that if the displacement, now the term of the no work, then if the displacement is 0, no work. Now next term is here, no work. No work. The first condition of no work is here, no displacement or displacement, no displacement, no displacement, no work. And second is here, no work when displacement is perpendicular to the force. No work when displacement no work when displacement is perpendicular to 0. Is perpendicular to force. So it is clear that no displacement, no work. Now we know that here work done. W equal to F into S. If the no displacement, so it is clear that displacement, if the displacement equal to 0, then W equal to F into 0, that work done will be 0. Now the first condition, no displacement, no work. And second condition is here, no work when displacement is perpendicular to force. Then angle between the force and displacement is 90 degree, and we know that here W equal to F into S cos theta, then W equal to F into S cos 90, then W equal to F into S, and the value of cos 90 equal to 0, then work done equal to 0. So in this condition, work done will be 0 if the displacement is perpendicular to the force, and second is no displacement, no work. If the displacement is 0, then work done will be also 0.